In our last lesson, we learned that it's possible to type in a lowercase word. The example that we used was the word text, and that Mathematica will treat that word as a symbol. If we haven't assigned anything to that symbol, then it appears in our notebook in a blue font. As soon as we use the set command, or the shortcut for the set command, which is equals, we can assign a value to that symbol, and then we can use the symbol in any place where we would expect to see that value. So for example, one of the things we did in our last lesson was we assigned the first part of Alice in Wonderland to the symbol text, and then we could do things with the word text that would be applied to that whole part of Alice in Wonderland. So this gives us a nice shorthand way of doing things in our notebook. Now when we start a new notebook, the symbols that we've already defined are still defined unless we quit Mathematica and start again, or unless we explicitly clear the values of all of the symbols. And so what happens at the beginning of each of these lessons is I use this command clear. I'm going to go in here and click inside the cell that contains it. I use this command clear with the special string to indicate that I want to clear all of the values that have been assigned so far. When I evaluate that, notice Shift Enter. Notice over on the left hand side it now says in 1. I have just started up this Mathematica session, so this is the first input that I've given it. And it doesn't actually give us an output, but we know that it has run that expression because it's changed to in 1 over here. So we're going to be looking at entities. So notice this HC is blue and begins with a lowercase letter, so that is an undefined symbol. In this expression, I have the equal sign, and then I have this Mathematica expression. Now when I evaluate this expression, it's going to run that code, and it's going to assign whatever the output of the expression is to the symbol HC. Let's try it. Click inside the cell, hold down Shift and press Enter or Return. This takes a little while longer to run because the information isn't actually stored on your computer. Mathematica goes out to the servers at Wolfram and it grabs the information and it downloads it back into the notebook. So what we have, if we look at this, is what we appear to have is a list. And if we're not sure if this is a list, we can actually check and see with the head command as we learned last class. Head of HC, Shift Enter, is a list. Okay. Now, just looking at the code, we see Canada country, and this formatting, the tan kind of rounded edged rectangle, tells us that this is an entity. It says Canada country, and there's this little tick box if we're okay with this interpretation. There might be other interpretations of the word Canada, but if we're okay with this one, we can click on the text box or this checkbox to let Mathematica know that that's the correct interpretation. The inside command is called entity class. Current country is Canada. That's what the little arrow means. And historical country is what it seems to be asking for. And once we have this class of entities, the entity list command gives them to us in a list. So British North America is a historical country that once occupied part of the territory where the current day country of Canada now exists. Vancouver Island was once a separate historical country, is now part of British Columbia, part of Canada, and so on. If we want to take apart a list, we have some simple commands that let us do that. We have quite a number of them, but I'll just show you a few of them right now. So here's a new command that we haven't seen before called character range. I'm just going to evaluate it so you can see what the output is. So we say character range capital X, capital Z. Those are both strings, and it outputs a list X, Y, Z. So we now see that character range appears to take a beginning character and an ending character and give us the range in between those two. Suppose we want to use the techniques from last class to make sure that this is the case. We can copy it, paste this in, and say, what if we change that X, for example, to an A, change this Z, say, to a G. Shift Enter gives us A through G. So that is apparently and actually what the character range command does. Now suppose we have that list x, y, z, and we ask ourselves, well, what's the first element in that list? We can use a command called first, give it the list, so I go Shift Enter, and it returns the first element in that list, x. There's a matching command called rest, which gives us the rest of the elements after the first one. So once we have taken out the x, the remaining structure is a list containing y and z. If we want, we could combine those commands with the head command. So for example, suppose I want to know what the first element of that character range list is. I can copy this expression here, Command C. I move down here until I see the horizontal cursor, click to create a place to enter, and then Command V to paste it in, or Control C and Control V on Windows. And now I can wrap this command with the head command. So what that's going to say is it's going to say character range x to z gives me those three characters in a list. First takes the first element, which in this case is the string containing x, and then I use the head command on it, and it shows me that x is in fact a string, as are the others. Now we can copy and paste entities or expressions containing entities, and they work just like other Mathematica code. So for example, we saw in this list, I'll just drive back up here, we see in this list that, say for example, British North America or Dominion of Newfoundland are elements of this, are historical countries that occupy the space, that once occupied the space where Canada now is. If I take one of those historical countries, say New France, if I put square brackets after that entity and in the string properties capitalized like that, it will show us all of the information that we can get about New France, the historical country. Its coordinates, these are latitude and longitude, current countries that it overlaps with, the date that this historical country ended or dissolved, and a number of other things. Polygons have to do with geographic information, which we will see a bit later. Now this list contains a number of entities. What are those entities? Well, if we wanted to know what those entities are, we could use, let me do it down here, we could say head of the first one of, so this is just what we did with the character range, but now I can actually copy this expression right here, Command C, paste it in, Command V. I have to put in the two closing brackets, and Shift Enter. And that tells me that these things inside this list are what are called entity properties, which is not surprising since this is an entity and we asked for its list of properties. If we want to request one of those properties, say for example which current countries did the historical country of New France cover, we have to ask for the canonical name of that property, and we do that with the property canonical names command as we see here. Shift Enter. So it tells us that the canonical name of what we're looking for is called current countries, and now we can create a new expression that says New France historical country, and in square brackets we ask for its current countries. So we hold down Shift, click Enter to evaluate this. So what was once New France covered area that is now the United States and Canada. There's usually more than one way to do things, and this is true in Mathematica too. Instead of using the canonical property name like we did here, we can just copy and paste that entity property to create an expression that looks like this, and it gives us the same answer. Now I want to take a second and draw your attention to something that we've implicitly done a number of times, because it's really good to try to be clear about this in your mind, especially as you're learning a new programming language. And that is, we have seen that a command takes certain arguments and it returns certain type of outputs. So for example, if we see the command that looks like this, we say to ourselves, the character range command takes a pair of strings as its arguments. I hold down Shift and press Enter, and it returns a list of strings as its output. Now, in the output format, the quotation marks around the strings are not displayed, and that's simply to make the outputs easier to read. But they're there. These are in fact X, Y, and Z are in fact one-character strings. If we look at some code, we can say to ourselves, character range command takes a pair of strings and returns a list of strings. But that list of strings is then what is given as the argument to the first command. So if we substitute the output of character range here into that expression, we can now say the first command takes a list and returns the first element. In this case, that first element happens to be a string. Here's an expression that we have looked at before, word counts, Shift-Enter. The word counts command takes a string, that's what the input is here, and it returns an association. That's an output that we saw last class. Alphabetic sort takes a list of strings and returns a list of strings. The plus command, in this case, takes a pair of integers and it returns an integer. The range command takes an integer and it returns a list of integers. The total command, something else we saw last lesson, takes a list of integers and returns an integer, in this case the sum of those 5 integers. Under different conditions, a command can take different numbers of arguments, so it's not just limited often to doing one thing. Range 5 by itself gives us the numbers from 1 to 5. Range 7, 11 gives us the numbers from 7 to 11. Range 7, 21, 3, 3 arguments, gives us the numbers 7, 10, 13, 16, 19. It's the numbers from 7 to 21 counting by threes. If we ask for the start date of a historical country, we get a different kind of, it takes a second to load this up, we get a different kind of output, and we can tell by the formatting that this is something special. It's an entity in its own right, but in this case the entity represents a year and not a historical country. And the same happens if we try Command-C, Command-V. If we try requesting the end date, it gives us an actual day rather than a year, but again we can see that this is a special entity in its own right. Now suppose we don't know what an entity is. So for example, what if we wanted to find all of the historical country entities that once occupied the territory that's now Hungary? We can copy and paste the expression that we started with at the very beginning, but if we don't know what the entity for Hungary is, we need a way to discover it. And in Mathematica, the way that we discover things is we type in an equal sign, or we type in an input. We start typing an input, and we just hit a single equal sign like this. And notice that it becomes that little orange equal sign. Now I can type in anything I want. And if it knows what that thing is, it will return the entity for me. And so we can do that to discover the entity for Hungary, the country. And if we copy the expression we just used and evaluate it, again it takes a bit of time to download the information from the server, we now have all of the historical countries, including places like Austria-Hungary and the Ottoman Empire, the Western Roman Empire, all of these historical countries that once occupied the place where the country of Hungary now is. There's one more thing that we can do with expressions, and that is we can do something like this. I'm just going to copy the first part of this, Command-C, Command-V, and now I'm going to put in the 2 square brackets because these end our expression. So right in here we need something, we need an entity, And we can actually create a place to type in a new entity by holding down Control and hitting equals. That gives us a little field where we can type in Hungary, like that, and Shift Enter, and it will evaluate the expression as before.